2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there. It's a specialized segment day, which means you're not going to be able to call in. Well, you can call, but no one's going to be here to answer it. But we still want to hear from you on Facebook, Twitter, our email questioning, and things of that nature. I'm Ernie Roberts. I'm your host of TN Learn's Mathline. And once again, this is one of those specialized segments days where we're going to do the math with you. You're going to get to sit back, relax. We ask you to get some pencils, some paper, and today maybe even some graphing paper, all right? Because this is where we're going to be going with. We're going to be working on some graphing of parabolas, and we're glad you've tuned in with us today. And let's see what that slate is all about today, all right? Let's see. A little bit of translation, please. Now, that doesn't mean language translation, but what it means is we're going to move that parabola that we discussed earlier this past week, or last week actually, and we're going to move it around a little bit. We're going to translate it across the picture and such a little bit today. And that's going to be kind of the theme of our next 2 days here, all right? So, and understand this is not your typical day that we have. We used to have live call-in on Thursday, but today is specialized segments. So again, sit back, relax. Let's do some math. Let's take a look at a quick picture here. This is our friend, the parabola. This is what we call the parent curve, all right? That moves around. We're going to see if we can move this little guy to up and down and shrink it and all sorts of good stuff today, all right? Called translating, all right? We're going to also use our lovely graphing calculator, which we're excited to have it back online with us today. We're going to have fun. You all sit back, relax, and let's do some good things. First of all, what we'd like to do is let's compare the graphs y equals x squared, and then we've got y equals x squared plus 2. I'm going to go ahead and tell you this is the parent graph, all right? That's the idea, what we just saw a picture of just a minute ago. And here we have our second graph. What we want to do is see how different is the second graph from the first one. And in comparing, there's going to be likenesses, but there's also going to be hopefully a very distinct difference. And we're going to hopefully come to some conclusions as to what's this plus or minus number on the end all about, all right? So let's take a look at our graphing calculator if we could, folks. And we're going to go back to the y equals, and I want to type it in with you here. We're going to put in y equals x. See where I've got that cursor going right up there to the x key. And we're going to square it. There's a little x squared button there. Never put the x squared button without an x attached in front of it, okay? And that's our first one, all right? Let's go to our second one, which is basically the same thing. It's x squared, but we got one little adjustment. We are going to add 2 to that one, and we're going to play graph. Here we go. Let's graph. How about that? There's the first one. And look what happened with the second one. Looks like the same picture. It just started a little bit higher up. All right. So we have, here's the first one. There is our value at 0, 0. That's a vertex, by the way. And notice what this did. It just basically was the same picture. It just shifted up 2 units. The translation, as we like to call it. So let's see what went on with that second one. All right, let's hit the trace on it here, and I'm going to work on the table while we are looking at the graph here on the graphing machine. We've got values. We know it's going to be 0 is the vertex. It tends to go right there with our grapher always goes to the y-axis for its first point, whether that's the vertex or not, but this time it actually is. And this is 0, 2. You say, Ernie, how'd you know that? I traced. There it is. 0, 2. See that? There we are. So we're going to create the table. And we're going to move along here. Let's put a -1. Let's go back a little bit. -1 squared. And that's going to give us a 3. Notice where it went to. And we'll hit the -2 squared. See what happens when we enter it. Just type -2 and press enter, and you've got it as 6, all right? So now let's go back to my table, back to my paper here, all right, that we've got going here. I'm building a table. There's my values, -2, 6, -1, 3, and I've got 0, 2. Now, folks, remember what we learned about parabolas. They are symmetric. Look at this beautiful symmetry right here around the y equals 0, or the y-axis value here, okay? The x equals 0 line, actually. And as we move here, what we're going to do is start noticing we're going to put some points on this thing. But we also need to pick up some positive points, all right? So how about what would happen at 1? And you know what? It's going to be 3. 1 squared plus 2 gives us 3. Remember, this is symmetry. This is symmetry around this y-axis, if you will, here. And this is the value where x is 0, all right? The vertex here is the origin, 0, 0. But we've got a new vertex for our second curve. We're going to put it up here in green in just a second for you, all right? And while we're at it, let's go ahead and put in 2. And you know what? It gives us a 6. When we put 2 squared and add 2 to that, we get 6 also. So we're ready to put our new graph up here. So here we are. There's 0, 2. Let's see. We've got -1 up. We go over -1 and up 3. And then we've got this 2, 6. So 1, 2, we're going to make it right in there. -2 and 6. There we go. We're going to play the same game over here. We're going to be at +1, 3. And then we're going to go to +2, 6. Just points. All we're doing here today. All right. And there is our new parabola. Notice how it works up there. And you say, Ernie, will those graphs ever cross each other? They're not going to. This is going to always be just a little bit ahead of it out here on this +2. But notice it's a shift. It's a translation, we like to call it. Our vertex on this one is 0, 2. We always put the x first on the y-intercept, and that's what it is. It's a nice y-intercept right there. And these other points give you the upward. It's also the typical normal side, because remember, this was y equals x squared plus 2. For those of you maybe just joining us, that's what my green curve is. This one, the parent curve in black, is simply y equals x squared. Again, what we're trying to do is compare, and the sizes are the same. It's just a shift. It's just a shift upward of 2 units on the y-axis. So everything on the green parabola shifts upward, all right? That's the effect. That's what the last number we add on is doing. It's moving it either up or down, it seems. Let's see if it does a down flow, all right? Let's take our next one here. Let's see what we got for our next one going here, all right? And while we're doing that, let me fix up a little bit here off our graphing calculator moment. And we're going to get rid of one of those. We're going to add another one here in just a second. Just patient with me. All right. Now, what we got here, the parent curve, once again, is y equals x squared. We will have that coming to you in just a second in black. And what we want to do is, what's the effect when we take x squared and we take a -4 to it? Now, remember just a minute ago we had x squared plus 2 translating up by 2 units off your y-axis. Let's see what happens when we go to the graphing calculator here and see what we can do on the next one here. Parent curve already in there for us. We're going to keep that one going. We want to see what happens when we tap in the x squared. Let's try that again. Hit x squared. There we go. Oh, clear. Try x. There we have it. Oh, let's try again. Clear. Y equals, back to it. There we go. Let's book down. That's the problem there. We got x. We're going to square it. Always interesting when those keys something fumbling around you there. Here we go. We had +2 last time. You know what? We're going to make that -4 this time. That's our new one, all right? And let's graph it and see what it looks like. Let's graph, see what it looks like. There we go. Parent graph right there. And here comes our second one, which you probably may have expected. That might go below us. Well, let's put a trace on it. We'll see where it goes. We want to go to the second. By the way, when we go to the second curve, we're going to either cursor down or cursor up. It will take you to the other one. And notice up there in the corner, you see it right there, folks? That it tells you which of the curves you're working with. We're working with the x squared -4. And we are right there at 0, -4. Now, while y'all are looking at the graph, let's just, I'm going to make a table on paper, but we're going to stay with the graph, all right, for just a minute. I'm going to start at 0, -4. That's going to be my middle. That's the vertex right there, all right? Now, let's put a -1. We'll work backwards. We'll work backwards a little bit. Put a -1 in there and see what we get. It's going to be -1 squared. We're going to add, or we're going to subtract 4 on it. Let's see what it gives us. It gives us -3, all right? It takes care of it for you. That's the beauty of the trace function, by the way. It takes you to where you're going, and it also gets you there accurately. Let's try -2 in for x. Type -2, press your enter, and we've got it at 0. So we've got -2, 0. Remember what I've said about symmetry? That means it's going to work the same way for 1 and 2. So let's see what's happening in our table at this point, all right? We've got a list of numbers here that we're going to make another graph with. We've got -2 and 0. That worked off our trace. We have -1, -3. also coming off the trace, 0, -4. And remember, by the symmetry, that means everything on the right side of our figure, because it's so beautifully symmetric, is going to match the left side here at -2. In other words, the thing we get at +2 on this one is going to be 0, all right? And with the 1, we are going to end up with -3 when we pump it in there, all right? And you can look at it that way as being basically 1 - 4, or in this case, 4 - 4 gives you 0. So it does work out, easy in this case to work with. And by the way, no matter what the parabola looks like, it's always going to be symmetric, always going to be symmetric. So once you get that vertex, and I circle that vertex because that's an important moment, all right? Now, let's plot these points, see where it's going to go, all right? We've got, first of all, I've got -2 and 0. Well, right there it is. You go to the left 2 and don't go anywhere up or down. And how about -1 and down 3? That's going to go left and down 3. And then we've got our new vertex. I told you about it. There it is at 0, -4. That's our vertex. That is the minimum of this graph. The minimum of this graph is the lowest point we're going to have, because now look what happens. At 1, we start coming back out of the slump here, so to speak. And here we go. At 2, we are back to 0. All right? And you start looking, and that makes this a lot easier when you realize in a quadratic or a parabola, what goes down has got to come back up, and it comes the exact same way. It comes back up the exact same way. It's the beauty of a parabola. Let's connect it and see what it looks like. Looks like it's going like this. And you know what? It's going to keep working. It's a translation. A little bit down. It's good. It's good. And notice what happens on this one. Simply, it basically shifted this parent curve down 4 units. So that's what the -4, by the way, this one was y equals x squared -4. So see, the x squared says, hey, it looks like the parent. It's just going to move 4 slots. It's going to move 4 slots, in this case, in a negative direction, down, 4 down, all right? So that's the translation business we're talking about. Now, let's take a look at a real interesting little problem here, all right? What it says here, we have y equals x squared, and we have y equals, a little bit different here, 4 minus x squared. Now, when we look at situations like that, let me clear my graphs out here. We'll get going new here. And when we do that, notice there is a big difference this time. What we have done, we have changed the sign of the x squared. It's now got a minus in front of it. And that's going to make a big difference in our graph. Let's see what happens. Let's see, I've got 4, and I'm going to subtract. I'm going to subtract x squared. And here we go. And we're going to hit enter. And we're going to see what happens when we decide to graph. So slide your cursor up to those graphs. Let's see. There's the parent. And there comes, that kind of makes a nice little design, doesn't it, when you put those together? It looks like one of those, I think one of those athletic brand names, which we aren't allowed to say on the air, are we? So, but anyway, there you go. It looks sort of like that. It's a cool little moment there. As you see, the second curve is moving, first of all, it's moving downward. It's opening downward. So it has a vertex. There it is. I'm pointing at it there with my cursor. And that becomes a maximum because it's at the top. It's at the top. So what we're going to do when we start tracing on this one, we're going to build another table. And we're going to see what happens on our second curve. So let's trace. And remember, we move the cursor down. And that picks up, as you see, right up there in the corner. Right up there in the corner, the y squared, y2, not y squared, but y2, that second y, is 4 minus x squared. So we're going to make a table on our graph here in just a second, but we're going to build it by tracing. We're going to use the trace to build it, all right? So let's first of all see, we already know what 0 and 4 does, so put that right in the middle of our table. And let's see where we're going to go. We're going to put in a -1 first and see what happens on this. It bounces all the way over to y equals 3, all right? So we put a -1 in there, goes to 3. We have also a -2, and we'll hit that. And that's back to 0. Okay, so -2 comes back to 0. And, you know, we're going to have that same thing happening, it seems like, for 1, just to make sure y'all believe me. If we put a 1 in there, you get the idea. You get 3. And then with a 2, we're going to be back to 0. So let's take a look at how this is going to graph on our paper. Because what we want to do, we want to take the values that came from the picture we saw on the grapher, and we want to translate to our graph paper, all right? And in this case, we're going to start at -2, 0. Right, there we go. That sounded familiar because we had that in our last point, didn't we? How about it? -1, and we're going to go up 3 this time. And 0, 4, that is our peak. There's our vertex, all right? And it's a maximum. By the way, its coordinates are going to be at 0, 4, all right? Bring it back down here. We've got 1 and 3. Well, go over 1 and up 3. There's that point. And go over 2 and don't go anywhere. There you are at 0. And we've got a nice, pretty parabola coming downward. I like those that come down better. It seems like they're easier to draw, all right? But anyway, there you go. And now you could even have a jaws shark mouth or something there. Call it that, whatever. But this is kind of what happens when we start putting curves and group things together. They start noticing some things about it. And that's a pretty cool little symmetric picture in the middle there, all right, between the green and the black parabolas. But that's the idea. Notice this time, because of the minus, the curve looks the same, except it's turned downward. So like I said, the top is the maximum, and it's open downward, the same size parabola, all right? That did not change. We had an x squared involved. Now, what we want to do here, I'm going to get rid of this comparing business, all right? Because we've done enough of that now. So we're going to lose the parent curve. We're going to lose the parent curve. We're just going to do some graphing, all right? We're just going to do some graphing. So let me get my calculator cleared, and we'll be good. Let's take a look at our next problem here, all right? Next problem, we're going to use the graphing calculator to take care of this one. 1/2 x squared minus 2, all right? That's the deal. Now notice something going on here, and some of you are probably already thinking, that minus 2 says it's going to shift down 2 units. That's true. That's true. The 1/2 is going to slow it down, remember. It's going to slow the curve down, so it's going to make it wider. It's going to make it wider. So let's type that one in on the grapher. Let's see what happens, and we'll put it up there. Let's do first y, and we're going to have 1/2, which is 1 divided by 2, by the way. Some of y'all wonder, how do we put fractions in on a graphing calculator? There we go, just 1 divided by 2. That's what a fraction is division. Hit your x, and let's square it. Let's square it, all right? And then we're going to subtract 2. We're going to subtract our 2 value from there. And we're going to get a pretty graph once we hit the graph button. And there it goes, there it goes, there it goes. Notice what happened. Parabola looks different. Well, it should, because it has now had 2 things affecting it. The 1/2 is helping it. It's keeping it upward because that's positive, all right? The vertex is still on the y-axis. That's going to happen until we throw something in for the x in the middle. We haven't done that. We're not going to do that today. We're going to keep you easy going on these, all right? And we're going to make a table. We're going to make a table. So go ahead and hit our trace button here, and it will help us out, especially when we start getting these old fractions come into play. So we got x, we got y, and in the middle looks like we got 0, -2. I'm going to go with that as my vertex until something else tells me to do it, and that'll be our next session that we get tomorrow. Now from here, let's see what happens. You know what? You know what, folks? Because I don't really like odd numbers to take half of them because it gets kind of strange. Let's just use the number -2. Let's use -2 on that and see what it does for us. It takes us to 0, all right? So I'm going to back it up with -2 because what we like to do is when we have a 1/2 effect like this is if we could get even numbers in there, they square out, they make nice values, all right? So we're going to put -2 in there, and it looks like, my friends, when we put in that, we get a 0, all right? Let's back it up to -4. 1 more unit to the left, or 2 more units to the left. Actually, we're in intervals of 2 this time. And let's press an enter on that. I get a 6. I get a 6. So that's telling me how this thing is going to open up a little bit, all right? Now, I could have used 1 and 3. That's fine. It'll give you some decimal values, and you're more than welcome to plot those in a minute. But remember what we said about the symmetry, Here's the left side. The right side should do the same. So let's go ahead and fill in the rest of our table, all right? Let's take a look at this thing now. Back to my paper here. Let's see what we've got going. Let's put a 2 and a 4. Because, again, symmetry. We want to have the negative side, there's the positive side, and guess what? When you put in a +2 in there, it is, yes, it's going to give us 0. And we put in the +4, it's going to give us 6, all right? And that's the symmetry. That's this axis of symmetry that's going on, which happens to be the y-axis in this case, all right? So let's graph these points. Let's graph these points and see what we've got. I think we've got a great picture here. We've got 0, -2, right there it is. Again, we're not going to have the parent curve to guide us, but remember this one's wider. This is going to be wider. We have also, looks like a -2, 0 right over here. And then we've got -4 up 6. So count your units. There we go. Got up to the top of our picture. There we go. And again, remember, this should be a nice mirror image across the other side. And at 2, we're at 0. And at 4, we are at 6. All right, so there we go. And remember, when you're putting in that 4, some of you may be trying to crank this out by hand. Remember, you put in 4 squared at 16, then you take half, which gives you that 8 minus the 2. So be careful, don't half the 4 and then square it. You don't want to do that. You remember, please excuse my dear Aunt Sally. Do those exponents first, all right? Let's do the curve. Let's do the curve. And there we go. Right up it goes. And folks, there we go again, right up to the top. Opens upward. It is a wider parabola than the parent, and the vertex, it's at 0, -2. This, folks, the y-axis, which is x equals 0, is your axis of symmetry. And notice the x value is at 0. It's going to always, whatever the vertex x value is, that will be your axis of symmetry as long as you're opening upward or downward, all right? So a little good graph there, a little bit different twist on it, all right? Our next one is going to twist us in a different way, all right? And we're going to take a look at this one. This one has a different look to it. It says y equals -2x squared plus 5, all right? And let's see, let me get these things cleared off over here. And what's happening here, notice the -2 says, hey, we're opening downward, but that's not less than 1, is it? Absolute value is not less than 1, is it, folks? So it's going to be a rather quick, fast-moving parabola, I like to call it. In other words, it's going to become more narrow. It's going to become narrow. It's going to get to its destination quicker. And here we got a plus 5 on the end of it, which tells me this little guy is going to go up high somewhere. Let's see. We'll clear out our graphs. And now let's take a look at the graphing calculator, see how we're going to put this one in. We're going to put it in with a negative. Be sure you use the negative key. Notice where my cursor is pointing. That's at the bottom. That's subtract. It only likes to subtract, all right? You got to use the negative in front of this thing. So we put a 2, we put our x, and we square. And then we tack on this plus 5. And let's see what this graph looks like. Here we go. And just what we expected. It's pretty tight. It's much more narrow than the parent graph that we've been looking at. It also opens downward. And look at the peak. It's right up there at 0.5. So I'm going to go ahead and get ready to graph this thing. But we're going to use the trace. We're going to use the trace and get our points and see where we're going to go from there. Hit the trace. There it is. In case y'all wondering, it's always in that top row, 4th over. That's where the trace happens. And again, it takes us right to the vertex on this one, just because that's where the intercept happens to be this time. It doesn't always, by the way, the vertex is not always going to be on the x and y axis. We will check on that next lesson, all right? We've got a 0 and a 5 happening, so let's take a look at it. And since we have whole numbers here, we don't have to worry about 2, 4, and all that. We can use 1 and 2 and -1 and -2. So let's go with -1 first. See where we're going. We're going to have -1 and 3. We're going to put in -2 and see what comes out of there. We get a -3. And then we'll notice that that's going to give us the other side. So let's take a look at our table here. Let's go ahead and move to our table here. From our trace values, remember what happens. We have a symmetry. There's our vertex right there, 0.5. And this time it's going to be at the top of the graph, so it makes it a maximum. And we're going to look at what happens with 1. Well, if you put 1 in there and you square it, you're going to get a 3. And if you put a 2 in there and square it, you're going to get that -3 business, all right? Let's plot those points and see what happens on our graph. It should look like what happened on the grapher. You see how the grapher looks right there? Let's see how our points plot back through, all right? So first one, we're going to have it right here on the paper here if we can. We have a 0.5, going to go right up the middle. That is our vertex, so count up 5 slots. There we are. And now let's start bringing it down. Got a -2, and we're going to go down 3. This thing is opening up real fast to the bottom, all right? We're going to look at -1, and it's going to match up with 3, okay? Same thing's going to happen over here. +1 is going to go with 3, so there we go, over 1, up 3. And then we've got 2 and down 3. And once again, curving it down, there we go. Probably comes out just a little bit better. There we go. So there you have it. Not that part. Not that part, but this part over there. But there's your graph. You've got your vertex up here at 0.5, and it is a maximum. It is a max point, all right? So when we work with parabolas, those are the basics, folks. That's the basics. See when the a squared coefficient is negative, opens downward. If it opens upward, it is positive, all right? And the last number, the C value as we like to call it, if it's positive, it's going to push you up. If it's going to be negative, it's going to push you down. Let's take a look at this one, last one here. Not going to graph it, but I'm going to go through the moments here. First of all, looking at this graph, vertex 0, 1. That's what we're going to notice right there because there's no x term in between here. So 0, 1, there's your intercept right there. It's going to open down. It is going to be because of the negative, 1/2, it's going to be a wide parabola. So it's going to open down in a wide fashion. And you know what else is going to happen there? You know what else is going to happen? Like I said, the shift is going to be 1 above the origin, all right? So that graph is going to shift up. Translation, translating, okay? So here we go. We look at our graphs and such. We do know what we have, what we want. Hey, what we're going to do next time is we're going to move it left and right and a little bit up and down at the same time, all right? So you don't want to miss out on that. But it's all about parabolas today, translating them, seeing where they end up. Thanks for tuning in. We'll see you tomorrow.